Alright, question number 8 is asking us to find all the zeros for the function, 8a anyway, all the zeros for the function 3x to the 4th power minus 6x squared. I'm just going to do this algebraically because I know that if I factor out 3x squared, it's going to make it easy to find the zeros. That just leaves an x squared here, and then minus 2 on the inside. I know if I make either one of these two terms 0 because of the law of zeros, that the entire function is good. That will solve for the entire function. So out here it's easy. If I make x 0, 0 times 3 is 0 times this is 0. So one of my answers is x equals 0. On the inside here I need a number squared to give me 2. 2 minus 2 is going to be 0. So that happens twice. That happens at x equals the square root of 2, because the square root of 2 squared is 2. But that also happens at x equals the negative square root of 2, because negative square root 2 squared is also 2. Alright, so there are the zeros. And it's also asking where it increases and where it decreases. Alright? What's going to happen? Here, let me put it in the calculator first. You can see if you graph that function, let's see if I can zoom in a little bit. If you graph that function, you can see where it increases and where it decreases, right? So it is, if you can see my little spider there, it is first decreasing, right? It's first decreasing, decreasing from negative infinity to, and then actually let me make my y go a little bit farther down. Let's try negative 5. I can see, good. Now if we can trace, you can see that it is, go back over to this side. Alright, here we start out from negative infinity all the way to, it looks about negative 1, negative 0.95. It's decreasing. Then it increases, I'm looking at the x value, then it increases to where x is 0. Then it's decreasing again to, here's the bottom, it decreases, and we're always looking at the x for the domain of where it's increasing and decreasing. It's decreasing from 0 to positive 1, okay? And then it's increasing again for infinity. So again, decreasing until negative 1, right? There's negative 1. Increasing at 0. Decreasing again until negative 1. And then increasing for infinity. Until infinity.